Hello, welcome to lesson 3.3. Today we will be talking about comparing and ordering rational numbers. Okay, so today we'll be talking about objectives. I can order fractions and decimals, and I can compare fractions and decimals. Ordering and comparing go hand in hand. Our standard will be from NS7A. Interpret statements of inequality as statements about the relative position of two numbers on a number line diagram. So we'll be visualizing where numbers fall on a number line. So remember that rational numbers are the in-between numbers. They're not the 1s, 2s, 3s, and 4s, or the -1s, -2s, -3s, and -4s. They are the numbers and all the possibilities in between, for example, a -1 and a -2, or a +1 and a +2, between any two numbers. All kinds of numbers can be fitting in between here. So there's an example on the screen there of some numbers that would fit in between those integers there. Okay, let's go on to a definition of equivalent. What does equivalent mean? Well, it has the word equal in it, or seems to, right? It means representing the same value. So if something is equivalent, it is the same number just written differently. All the time we are finding equivalent fractions because they are the same fraction just written differently. Fractions and decimals are equivalent if they represent the same value. So here's our number line. There's 0, 0.1. Now these are divided into sections of 10, right? So there's 0.2 or 2 tenths, 3 tenths, 4 tenths, 5 tenths, 6 tenths, 7 tenths, 8 tenths, 9 tenths, 10 tenths. 10 tenths is really 1. So in between 0 and 1, between 0 and 1, you can have all kinds of different numbers. Here we are dividing it into groups of tenths, 1/10, so 10 groups. And then you can see that we also can write those decimals as fractions. So 1/10 is really the fraction, 1 on the top, 10 on the bottom, 1/10. 2 tenths is really 2 on the top, 10 on the bottom, etc. All the way up to 10 over 10, which is 1, because any number over itself is 1. 10 over 10 is 1, 12 over 12 is 1, 15 over 15 is 1, 1 million over 1 million is equal to 1. And then on the bottom there, you will also see that broken up into fifths. So if you were to reduce 2 tenths, you would reduce it to 1/5. So 0.2 or 2 tenths up here, let me get my spotlight. 2 tenths is the same as 2 tenths written as a fraction, which is the same as 1/5 at the bottom there, when that black bar goes away. 1/5 written as a fraction. Those are all equivalent fractions. The same goes with 4 tenths. Below that, you have 4 tenths as a fraction, and then you have 2/5 as a fraction. 5 tenths can be written as 5 over 10, and it can also be written as 1/2 because it is also 1/2. And then you see 6 tenths can be written as 3/5 as well, and then 8 tenths can be written as 4/5, and then 10 tenths can be written as 5/5 because it's really 1. And then you have it divided into fourths. So I always think of fourths in terms of quarters. There are 4 quarters in a dollar. So each quarter is worth 25 cents. So if I were to put that in a decimal, I would put let me do this in red here. I would put 0.25, and that would go right in between the 2 tenths and the 3 tenths. And if I was to do 2/4, that's the same as 0.5 because it's 1/2. And if I were to do 3/4, that's worth 75 cents. So I put my 0.75 here. And notice that 0.5 is already 50 cents. It's like 0.50, same thing. So there you can also see where the 1/4, the 2/4, and the 3/4 will fall on the number line. And you actually have this activity to do as one of your assignments. So you will get to see that again. Clear that away. Okay, here's our number line again. Find a fraction that is equivalent to 0.4 or 4/10. What fraction is equivalent to the spot right here? I bet you can tell. Did you say 4/10? Then you are correct, 4/10. Find a decimal that is equivalent to 4/5. So where is 4/5? Let's find it. It's way down here. Circle that. Find a decimal equivalent to 4/5. Well, all you have to do is draw your line straight up and you find it right here. So 0.8 is equivalent to 4/5. Where's my number? Oh, I gotta go back. I went too far. Let me go back. Okay, go again now. So click. Oh, we're still too far. What is going on here? Sorry about that. Did that. We're back to here. All right, so we did find the equivalent to 0.4, and that was 4/10. Okay, back to where we were. Find a decimal that's equivalent to 4/5, and we decided that it was, well, that's not a decimal. Should be find a fraction that is equivalent to 4/5. That is incorrect. Okay, I'm going to change the wording. Find a, not that, no, that's okay. Find a decimal that is equivalent to 4/5. I'm going to X these off because they are not. So go straight up, it's 0.8, like we said. So glitch in my computer program there. That is the answer. That is a decimal equivalent to 4/5. All right, let us move on. Clear that. Now that we've had all these craziness going on here. Find a fraction that is equivalent to 0.25. We had that on the last slide. 0.25 was here. And 0.75 was here. So what fraction would be equivalent to 0.25? So you go straight down. And there you find 1/4. So hopefully that's what's going to pop up here. It is, yay, okay. Find a decimal that is equivalent to 4/5. There it is again. Let's see what happens. There's our 0.8. Okay, now it's working. Find two fractions that are equivalent to 1.0. You see two fractions that are equivalent to 1.0? Do you see, if I were to go down here, what ones are they? Yeah, 10/10 and 5/5. There's 10/10 and there's 5/5. Move myself over there a little. Okay, find a decimal that is equivalent to 3/4. Let's erase this. So let's find 3/4. Where is that? We circle it. Now we need a decimal that's equivalent to 3/4. Which one would it be? That's like 3/4. What is 3/4 worth? 3/4 are worth how many cents? 75 cents. You should find this one. So let's hope that's what pops up here. Yay, there it is. Okay. All right, moving on. Finding equivalent rational numbers. What decimal is equivalent to 1 7/10? 1 7/10. 1.7. That's like saying you have a number line and you have the numbers 1 and you have the numbers 2. So this is this section divided out in a bigger area so you can see it. And then you divide each section into 10 parts. 1, 2, 3, 4, 5, 6, 7, 8, 9, that should be 10. 1, 2, 3, 4, 5, 6, 7, 8, 9. Do I need one more? 10. There. So there's your 10 sections. So 1, 2, 3, 4, 5, 6, 7. This is the 0.7 spot. So that is really 7 parts out of 10. And because we passed the 1 over here, we would write 1.7. That means 1 and 7/10. Read the decimal as the word and. Okay. Let me clear my drawings now. There is 1.7 about. What decimal is equivalent to -2 3/4? So again, we're going to be looking at the area between -2 and -3. So we'll put -2 here, and we'll put -3 here, and we're just taking this small section and showing it in more detail. So because I have a 4 here, I want to divide my section into fourths. So I'm going to try to do it equally. 1, 2, 3, 4. And they should be about the same size. So this would be -2 1/4. This would be -2 1/2 or 2/4. We'll call it 2/4, but 1/2 is the same thing. It's equivalent. And this is -2 3/4. So that's what we're looking for, -2 3/4. But what would be that? What would that be as a decimal? Remember, with the fourths, we think of quarters. This would be -2 point, how much is 1/4 worth? 25 cents. How much are 2/4 worth? Right, 50 cents. So 2.50. The 2 has to go in the front because I have a whole number 2 up here. So what would this one be? -2 point, yes, 3/4 are worth 75 cents. So now, should be able to get that number popping up there, -2.75. Erase this a little bit and we should see our number pop up here. There it is on the smaller scale. So this whole bigger section here is really this small section right down here. So that's about where -2 3/4 would be. It's closer to the -3 than it is to the -2. Now I'm going to clear this. What fraction is equivalent to 4.25? Well, I know I have to go past the 4, right? But not all the way to 5. So I should draw a little 5 here. 5. So we know we're going to be between 4 and we're going to be between 5. What is it broken into? How many parts? Well, we see a 0.25 here. So it's broken into fourths, quarter size. So this would be our 4. This would be our 5. And this would be, let's put our little mark here by 4 and by 5. There's 1/4, 2/4, and 3/4. So this is going to be 4.25. That's the first quarter. The next quarter again would be 4.50 or 4.5. And then 4 point, how much is 3/4 worth? Yes, 75 cents. Okay, so what fraction would be equivalent to 4.25? 4 25/100 or 4 and how many quarters in a dollar, or how many quarters 4.25? 1/4 out of 4 that make up the dollar, right? So let's see if that pops up for us. Yes, it does. 4 1/4. And then we'll find it on our number line there. It's about right here. It's a little past the 4. Name a decimal between 0.4 and 0.5. So now we're talking decimals here. So not whole numbers anymore. This is 0.4 and this is 0.5. 5. Right here, that's a 0. So which number could come in between these two? Can you think of one? What could be? Could we do this one as 0.41? And couldn't we divide this into 10 parts again? But they'd be really small and hard to do. And then the first one would be 0.41. This one would be 0.42. That would fit in between there. This one would be 0.43. And I can't fit all of this on this little computer area here. 0.44, 0.45, 0.46, 0.47, 0.48, 0.49, 0.5. So that's what should pop up, one of those numbers, and 0.45 is exactly in between 0.4 and 0.5. But you could technically have picked any one of those numbers I was just saying. Oh, I gotta clear my drawings. And now it is your turn. I will see you back in a moment. Or if you're doing this on YouTube, you can do the whole thing at the end, or you can stop now and do just the your turn part 1. Answer those questions on a separate tab. Welcome back. Ordering fractions and decimals. You can order fractions and decimals using one of 2 methods. Method 1 is you're going to change all your fractions into decimals. And we learned how to do that. We'll review that today. Method 2, you can change all your decimals into fractions. And we learned that as well. So we'll review that as well. Okay, we're going to order these numbers from least to greatest. There they are. 0.2 or 2/10, 3/4, 1/2, and 1/4. We're going to show both methods, but if you were looking at this, which method would require the least amount of work, do you think? Well, this is the only one that's the oddball out, isn't it? The other ones are already fractions. So I could change just this decimal into a fraction and use method 2 and only have to do one number. But because I want to show you both methods, I am going to do both. So let's move on. Method 1, you're going to change all the fractions into decimals, okay? So there's the numbers again. We have to put them in order. Step 1, change the fractions into decimals. So there's 3/4. We're going to make that a decimal. How do we do that? Right, you have to divide. What number goes on the inside? The 3. What number goes on the outside? The 4. And then we divide, but we can't divide a 4 into a 3. What is that? We have to put a decimal point and a 0. And then we put the decimal point above, right where the decimal is. Got to put it in the same spot. Then we start dividing and we pretend like the decimal is no longer here, and we take 30 divided by 4. As close as we can get is 7. Then we multiply. 4 times 7 is 28. And then we subtract 30 minus 28. Borrow from the 3 and make it a 2. Change the 0 to a 10 and subtract. 10 minus 8 is 2. And then 2 minus 2 is nothing, right? So we don't have to put that 0 down. Are we finished? No, we are not. We have a remainder, so we have to keep going. In order to keep going, we have to put another 0 right there. And then we have to bring it down next to our 2. Now we take 4 and divide it by, we take 20 and divide it by 4. That will give us 5, and then we multiply 4 times 5. That is 20, and then we subtract 20 minus 20 is 0. Now we are finished because we have a 0 remainder. So 3/4 is equal to 0.75 as a decimal. We learned that just about a couple slides back when we talked about 3/4 equals 75 cents. The next fraction is 1/2, and we have to change that into a decimal. Which number on the inside? Yes, the 1. Which number on the outside? The 2. Can't take 2 into 1, so we have to add a decimal and a 0. Then we have to bring the decimal up to the top right away so we don't forget. And now we just divide 2 into 10 like normal. 2 goes into 10 5 times. 2 times 5 is 10. Subtract. 10 minus 10 is 0. We're done because that one has a remainder of 0. So 1/2 is equal to 0.5 or 5/10. Next one is 1/4, but you already know the answer to this one from the previous slides, right? How much is 1/4 worth? Exactly, 25 cents or 0.25. So 1 on the inside, 4 on the outside. We can't divide a 4 into a 1, so we have to add a decimal point and a 0. Divide the 4 into 10 after we put our decimal up there. Goes in there twice. 2 times 4 is 8. 10 minus 8 is 2. But we're not finished. We don't have a remainder of 0 yet, so we're going to add another 0 to our 10. And now we have 100, and we're going to bring down the 0 right next to the 2. Now we have to divide 20 by 4. How many times does 4 go into 20? Yes, 5 times. And then we multiply. 4 times 5 is 20. We subtract. 20 minus 20 is 0. We are done because we have a 0 remainder. So 1/4 is equal to 0.25. And you'll start memorizing these pretty quickly with this. So you really should memorize 1/4, 1/2, and 3/4 as a decimal equivalent. So now we are able to order our decimals and our fractions. So we're going to graph the numbers on a number line. So there's our numbers. There's our number line. Notice how our number line is divided into 10 sections. And there is what we decided 3/4 was equal to, and what 1/2 was equal to, and what 1/4 was equal to. So now we're going to plot all those decimals on the number line. So the first one is 0.2, 2/10. That one's easy. It's already done for us, right? So there's where 2/10 would go. 3/4 is 0.75. Where's that going to go? Right in between the 0.7 and the 0.8. Right there. What about 1/2? Where does that go? Right there. Right on the 0.5. And what about 1/4? That's really 0.25. Where does that go? Right in between 0.2 and 0.3. There we are. Now we have ordered them from least to greatest. And our last step for method 1, there's our number line again, is to list them in order from least to greatest. So I'm rewriting them back in their original way so that I remember what's what. So remember the 1/4 was the 0.25, the 1/2 was the 0.5, and the 3/4 was the 0.75. So order the numbers from left to right for least to greatest, or from right to left for greatest to least. Since we want least to greatest, we're going to go from left, this is the smallest, to greatest, this is the biggest. So there's your answer. 0.02 or 0.2 is first, then comes 1/4, then 1/2, and then 3/4 is the biggest among those numbers. That is method 1. We changed all of the fractions into decimals. Now we're going to do method 2. We're going to change all of the decimals into fractions. This one will take a little bit less time just because we had 3 fractions to start with. Order these numbers from least to greatest, same numbers. Step 1, this time we're going to change the decimal into a fraction. So 0.2, how do I make that a fraction? Well, think about our decimal place value. You have tenths, you have hundreds, and you have thousands with a TH. Here's your decimal point. So you're going to put the 0.2 where? Right there, right? Oh, there's my arrow. Didn't need it. So I'm going to put my 2 right there. So I would say that as the number 2/10. So that, how do you say 2? How do you show 2/10 as a fraction? Well, you put the 2 on the top and the 10 on the bottom. 2/10. So there. Now, can we order our fractions? Let's see. Graph the numbers on a number line using the fraction equivalents. There's our numbers. And we decided that 2/10 was equal to 2/10. Nothing's happening. There we are, 2/10. Oh, we put it down here on the bottom of the number line. So 2/10 right here, and we have this number line divided into 10 sections. Where is 3/4 going to go on this number line? Now it's in tenths. Well, look below at the bottom when the black bar goes away. 1/4 is down there, 1/2, and 3/4. See them in the blue there at the bottom? So there's your 2/10. There's your 3/4. There's your 1/2. And there's your 1/4. And the reason I knew where 1/4 was in between the 2 and the 3/10 is because I divided my number line into fourths. The blue lines here and here and here represent that I have a section, draw a picture here. I have a section here of 1/4. This is 2/4. This is 3/4. And this is 4/4. So I have that section. And now what's our next step? Just like method 1, we're going to order the numbers on the number line based on, since it's least to greatest, we're going to read them from left to right. So let's put them back in their original format. So 2/10, then comes 1/4, then 1/2, and then 3/4. All right. Let's use method 1 to change all the fractions into decimals. So here's our new numbers, 0.85, which is 85 hundredths, 3/5, 15 hundredths, and 7/10. We have to order them, and notice the instructions tell us to order them from greatest to least. So the opposite way this time. Step 1, we're going to change the fractions into decimals. This is method 1. So when you're doing this, you have the option of using method 1 or method 2. So we're going to change the fractions into decimals. So we have 7/10. How do we change that into a decimal? We put the 7 on the inside and the 10 on the outside. We can't take a 10 and divide it into a smaller number, a 7. So we have to put a decimal point and a 0. And then we put the decimal point above right away so we don't forget. That's easy to forget. Now we divide 10 into just 70. How many 10s go into 70? Right, 10 times 7, right, gives you 70. So then we multiply 10 times 7, we get 70, we subtract, and we get no remainder, so we're done. So 7/10 is 0.7 as a decimal, which you probably already knew that from the first slides, but we wanted to show you why that works. And the other one we have to change is 3/5. Oh, I was just going to show you the other way. So 7/10, you can do it without dividing by just placing the 7 in your place value chart right down here, which when the black box goes away, go away black box, there we are. The 7 goes right there, and that's 7/10. So that's another way of thinking about it. So 7/10 equals 7/10 or 0.7. So you have a couple ways to do that one. Okay, now 3/5. So we're going to divide 3 on the inside, 5 on the outside. We can't take 5 into a smaller number of 3, so we're going to add a decimal point and a 0. Put our decimal point right above right away. And now we're going to divide 5 into 30. That goes 6 times. 5 times 6 is 30. Subtract 30 minus 30, we get 0 remainder. So 3/5 is equal to 0.6. Okay, now we have all the numbers in decimal format. So now our next step is to graph them. So let's go to the next page. There's our numbers. There's our number line divided into 10 sections. We said 3/5 was equal to 0.6 and 7/10 was equal to 0.7. Now let's just plot and graph these. So 0.85 is our first one. That's going to be right in between the 0.8 and the 0.9. There it is. Now 3/5 is really equal to 0.6. That one should be easy to find on the graph. Right there. There's 0.6. 0.15 isn't going to be in between the 0.1 and the 0.2. Right there. And then 7/10 is 0.7. That one's easy to find on the graph. Right there. Now that we have them ordered on our number line, step 3 then, bring our number line back. There's our numbers. There's our number line with our dots in the right spot. We're going to label our dots. So 0.15 is our first dot. 7/10 is over there. 3/5 is there. And 0.85 is there. So now we want to order them from greatest to least. So we're going to follow the rule that shows us from right to left for greatest to least. So the biggest number is this one. This is the next biggest, and smallest. So let's order those in order. There they are, 0.85, 7/10, 3/5, and 0.15. That's method 1. If you like that method better, use that one. Now I'm going to show you method 2. Same numbers. This time I'm going to change the decimals into fractions. So change the decimals into fractions. 0.85, how do I do that? Decimal place values, tens, hundreds, thousands. I have to put the 8 and the 5 in their spots. There they are. And it lands in the 100 spot. The farthest spot to the right it lands is the 100 spot. So I have to put my number over 100. So 0.85 is equal to 85 hundredths, or 85 over 100. Okay? Then we have to do the same thing with 0.15. So we're going to put our tenths, our hundredths, and our thousands again. And we're going to put 0.15 on our spots here. And since the 5 ended up in the 100 spot, we're going to call it 15 hundredths. And we're going to label that as 15 on top with 100 on the bottom. So now we have all of our decimals turned into fractions. Go to the next screen, bring our numbers down again. This time we're going to graph them. So we decided 0.85 was really 85 over 100 and 0.15 was really 15 over 100. So now let's bring our graph down. This is an interesting graph. How did I divide this? Well, I said this was 10 parts out of 100, 20 parts out of 100, 30 parts out of 100, 40, 50, 60, 70, 80, 90 over 100. And then this would be 100 over 100, or 1. So let's put our decimals in the right spot. And just so you know, 10 over 100 reduces down to 1/10. 20 over 100 reduces down to 2/10. 30 over 100 reduces down to 3/10, etc. So it's the same scale system that we had on the previous example. Why do I have blue marks here? Well, we'll see. Okay, I'm also putting 1/2 in down at the bottom. You'll see that in the green when the black box disappears. There we are. And you'll also see the fifths that I'm putting in. Every 2 marks of a 10th is 1/5. So what I mean by that is that, got my circle here. Every 2 tick marks is 1/5. Every 2 more tick marks is 2/5. Every 2 more tick marks is 3/5. 2 more is 4/5, and then 2 more is 5/5, or 1. So that's how they compare to the tenths. Okay, so now we can put our numbers in the right spot. So 85 hundredths is in between 80 hundredths and 90 hundredths, right in the middle there. 3/5, well, we've got that labeled for us in the pink. So 3/5 is right there. It's the same as 60 over 100, or 6/10. Then 15 hundredths, that's right in between the 10 over 100 and the 20 over 100. 15 hundredths. And finally 7/10, that's easy. It's already labeled for us there as 70 over 100, or 7/10. There is our ordering. And now we want greatest to least, so we're going to take it from right to left. So on the next screen here, we'll bring those numbers back. We're going to order from right to left. There's our number line. So what's the biggest? 0.85, 7/10, 3/5, and 0.15 is the smallest. So that's method 2. If you like that method better, you can use that method. Okay, now you get to try ordering some fractions and decimals. See you back in a minute. Welcome back. Now we're going to focus on some higher order thinking. If you know the order from least to greatest of 5 negative rational numbers, how can you use that information to order the absolute values of those numbers from least to greatest? Okay, we have 5 negative rational numbers. What do you know about numbers that are negative and then you take their absolute value? Right, their absolute value is positive always. So how is that going to work? Let's do an example to see what happens. So here's 5 negative numbers in order from least to greatest. I've already put them in order for you. This is the least. This is the greatest. Now I want to take their absolute values. Their absolute values will all be positive. So the new numbers are positive 3.5, positive 3 1/4, positive 2.25, positive 1 1/2, and positive 0.5. How do I order those from least to greatest? Which one of these is least now when you think of it in positive terms? Right, 0.5. So the order of the absolute value from least to greatest will be the reverse of the order before their absolute values. So this is how they look after, that black bar again, this is how they look after you order them by finding their absolute value. The smallest, that was the smallest before, is now on the other side, right? It's on the left side instead of the right. Okay, I encourage you to try that with some examples of your own. So you get to try this for a moment and I'll see you back. Okay, we are at the end of our lesson and I should bring myself back. So your lesson 3.3 will be on your Google Classroom account. And I will say goodbye to you and have a great day. We'll see you soon. Bye.